So hello viewers, in this video we are going to see that how we can configure OSPF inside Cisco Packet Tracer. So we'll take 3 routers and 2 hosts or multiple hosts to connect with the topology. We'll make the topology, we'll assign the IP address, we'll assign the default gateways, and we'll configure the OSPF on the routers. So yeah, without wasting much time, let's get started. So if you are new to this video or first time on our channel, consider subscribing to this channel where we cover all the concept, or not all the concept, but most of the concept that we cover on this channel are networking related. And yeah, if you are not aware about OSPF and how it works, what are the packet types, and pretty much if you are blank about OSPF working, then consider watching our previous videos. I'll have a link on the I button over here, or you can just go and check out the link. I'll make sure to add it in the description box. So yeah, now let me make the topology first of all from the on the Cisco Packet Tracer. So we'll see you after I make the basic topology. So if you see, these are the devices that we will going to take or encounter in our topology. So if you see, we have one subnet over here, then we have 3 routers, 1841 routers that we have took from this section where it says network devices, and you have this 1841 router. Then we took this switch 295024 and we have added to this topology. Then from the end devices we took a couple of PCs and laptops, and we had arranged in this manner. Now let me just connect all the devices in the manner. So we'll see you after I connect all those devices. So yeah, if you see, I have connected all the devices, but I am yet to assign the IP addresses. But if you see the IP address allocation plan, so I will be taking 192.168.10.0/24 subnet mask or the network identifier for this whole network. So I'll take 10.1 as in gateway IP, then all the devices will start. I'll assign addresses starting from 10.2. Over here I'll do the same, where I'll assign the default gateway as 192.168.20.1 over here, and then all the devices will be starting the IP address from 20.2. Then if you see, between these two routers, router 0 and 1, I will be taking 10.10.1.0/30, so probably 30.1 over here and 30.2 over here, and vice versa like this. So 2.1 over here and 2.2 over here, so that all the .2s will be connected to router 1, and we'll have a basic idea about how are the interface connected. So let me assign the IP addresses and we'll meet you. So if you see, I have configured all the end devices but yet to configure the routers. So if you see, on the PC0 on the left hand side of this network, where we have 192.168.10.0/24 network. So if you see, on default gateway I have configured, as I said, 192.168.10.1, and I have assigned this 10.2 and 10.3 over here. Now if you see, if I'll go inside the desktop and terminal, not terminal, if I go to command prompt, and if I'll just write ping 192.168.10.3, which is the IP address of laptop 0, I will have a reply from over here, because those are connected through a switch and they are layer 2 device. They are currently communicating through layer 2 device, but they can't go over and talk to this 20.2 because they don't have a route even to go from this device to this device. So we are yet to configure the IP addresses over here as well and configure the routing. So let me just meet you after I assign the IP addresses on the routers. So yeah, if you see, now I have configured IP addresses on each of the routers also, but still if you see, if we ping from let's say PC0 to PC1, so let's say if I'll ping 192.168.20.2, it will say like destination host is unreachable. So reply is coming from 192.168.10.1, which is our default gateway, which is nothing but this router. Now this router doesn't have a route to go to this PC1. Basically, if I'll say for the IP address, so it doesn't have a route to go to 192.168.20.2. So if we just go on the CLI, and now if we just go to this configuration mode, and if we just type show IP route, so if you see, it doesn't have a IP address 192.168.20.0/30 network here in the IP or the IP routing table of this device. So let's configure a routing protocol OSPF, and then let's learn how we can configure OSPF so that all these routes can be exchanged through these devices and they can have a communication. Basically these two devices can have a communication. So let's learn that. So if you are aware about OSPF configuration or the theory part, so we had covered like OSPF can be working on the single area, so entire network can be in the single area, and we must have area 0 inside it, or it can work on multiple areas. So in this video we are going to see that how we can configure the single area OSPF in this entire topology. So whenever we are going to say OSPF area, we'll be configuring area 0. And if you see, so this is the configuration of router 0 and this is the configuration of router 1. We are going to see that how to configure, but for the router 0 and router 1, just for you to have a sample in the mind. So this is the sample configuration for router 0 and router 1. So if you see, we have configured OSPF routing process with the process ID 1 over here also, and over here in the router. So actually both in the both router 0 and router 1. And if you see, we have first thing is that we are required to provide a router ID. So if you see, we have 10.10.10.1, and over here on the router 1 we have 10.10.10.2. So it's necessary that we have different router IDs for all the routers, so they can be aware about router IDs. And one thing to note, that if we are not providing this router ID, by default whatever the highest prefix or of any of the interface that we have configured, those will be taken automatically as a router ID over here by the router. Now if you see, we have this line which is passive interface default, so that means all the interface by default will be on passive mode. So that means they won't send the OSPF hello packets. So by default, why we do this is like we might have multiple ports inside our router, but we want to enable the OSPF packets through some of the interfaces only. So let's say if we talk about over here, or for the router 0, we might not want to send the OSPF packets over here on the fast Ethernet 0/1 port. So for that we do that command, and but we want to enable the OSPF hello packets for this fast Ethernet 0/1 port, which is connected to router 0 or router 1. So that's why we have passive interface default by default mentioned on both of the routers, and then manually we configure no passive interface for the interfaces that we want to enable OSPF hello packet. So this is the configuration. And on router 0, if you see, so just a second, so on the router 0, if you see, we have one interface connected to router 1 and one interface connected to router 2. So that's why on the router 1 we have both of the interface enabled as an OSPF, under the OSPF as no passive interface. Now if you see, under the OSPF router process, we have a network, then whatever the network that we want to advertise and in which area. So that command that we have written over here. Now as I said, we'll be configuring the entire OSPF in the single area. So all the routes that we want to advertise, so for router 0 we want to advertise 10.10.10 and 192.168.10.0, so that we are advertising using area 0, or you can also say that we are advertising that inside area 0. Now for the router 1, if you see, we want to advertise 10.10.10 and 10.10.20/30, so that that's what we have written over here, and as I said earlier, this is area 0 only. Now you can consider this configuration for so basically inside the router we can configure multiple OSPF processes, but you can ignore this router OSPF with the process ID 2 that we have configured on the router 1. So this is misconfiguration that by mistake I created the router process ID with the OSPF process ID with the 2. So you can ignore this configuration as of now. So this is the default configuration or example configuration for the OSPF. So now if I just if you want to verify, so being in this global configuration mode, not in the configure terminal mode. So if I just write over here show IP OSPF neighbor, so you will have an 10.10.10.2 router ID neighbor ID if you see, which is the neighbor ID of router 1 that we have provided. Then you can visit the state which is full DR, and now if you know the concept of DR and BDR, so that's what we have learned in our theory session. So this router is being elected as a designated router, so router 1 is being selected as a designated router. Now this is the dead time, this is the IP address through which what is the interface through which this neighbor is connected, and interface. So this is the information that we can see, and we can also see what are the routes that are advertised by this neighbor. So how we can do that is like we can just go to show IP route. So if you see, we have a route coming from OSPF learnt by OSPF process, which is 10.10.20, and it is learnt via 10.10.1.2, which is the fast Ethernet 0/1. So which is nothing but this IP address that is connected through this router. So whenever we want to go to 10.10.20, let's say if packet is coming from PC0 for 10.10.20 network, and it will come to router 0. So router 0 will see that, oh yeah, we can go to this network via fast Ethernet 0/1, and packet will be transferred or transmitted to this interface. So that's how OSPF works. Now we will see how to configure the OSPF protocol or OSPF for router 0 between router 0 and router 2. Now before that, what we can do is we can also verify on the router 1 that is the routers or is this network is being addressed or being advertised on the router 0. So again, to do that, what we can do is show IP route. And if you see, we have one route 192.168.10.0/24 learned via OSPF, and it is reachable via 10.10.11, which is fast Ethernet 0/0. So yeah, OSPF is working pretty well for router 0 and router 1. Now let's see how we can configure router 2. So yeah, we are on the CLI mode of router 2. Basically we can have an enable mode, then we can throw this command show IP route. So we have pretty much the sample all the connected interfaces IP addresses shown over here, because right now we have not enabled the OSPF. Now we can also see the show IP OSPF neighbor. So we are not having any neighbors right now. So yeah, that's it for now. We can go to global configuration, global configure terminal mode. Now we are inside that mode. Now what we can do is we can have this command, which is router OSPF, and now we can specify the process ID that we want. So following the current pattern, let's consider the OSPF router ID, process ID as 1. Now we can specify the router ID, so 10.10.10.3. So we have 10.10.10.1 over here, 10.10.10.2 over here in the router 0, so 3 for the router 2. Now we can have a passive interface default. So all the interfaces of router 2 won't advertise OSPF hello by default. Now, so we can see what is the interface that is connected to router 1. So as it is fast internet 0/1, we will enable like this, no passive interface fast Ethernet 0/1. So OSPF hello packets will be sent through this interface only. Now we can mention what are the networks that we want to advertise in which area. So we have network 10.10.2.0 and the subnet mask is 255.255.252, which should be advertised inside area 0, right? And now we have another route which is having subnet mask 255.255.255 and the IP address is, or the network ID is so yeah, we can have something like this: 250 255 255 and then 192.168 and then 20.0. So yeah, both of these IP addresses are now advertising inside area 0. So that's pretty much it that we want to do for the OSPF configuration. Now what we can do is we can go inside the global configuration mode, or the one level below the global configuration mode, and then we can hit this show IP OSPF neighbor command. And if you see, we have this 10.10.10.2 neighbor which is appearing as an designated router. And if you see, if we hit that command show IP OSPF neighbor, we have two neighbor and both of these are border or the backup designated router. Now if we just want to see what are the routes that are advertised by all of the OSPF neighbor, or the one neighbor which is router 1, so we can have show IP route over here. And if you see, we have two networks, 10.10.10 which is advertised via OSPF and it is reachable via 10.10.2.2 which is fast Ethernet 0/1. Also we have 192.168.10.0 which is learned by OSPF and it is reachable via 10.10.2.2, also fast Ethernet 0/1, because both of the networks are reachable via this router only. Yeah, and we can now also hit the router 1 and we can now hit show IP route command. So if you see, all the networks are advertised like this and we have all the routes, both of the routes over here. So now if we want to ping the devices, it should work. So let's just go to command prompt, and if we just now hit 192.168.20.2, so first packet might stuck at some of the point, but subsequent packet now onwards won't be stuck, because the first packet will go to ARP because it doesn't have the MAC address of 192.168.20.2. So first ARP will be sent and it will be having a basically request timeout, because ARP will take some time, and then the subsequent packet will have a successful reply. But now onwards it won't have any delays. So yeah, that's how we can configure OSPF. And one more thing to note, that if you want to observe what are the packets type that are exchanged, so if you can just go to simulation menu, so we can have a simulation over here and we can wait until we see some of the packets. So yeah, now we see a packet, blue colored packet coming from router 0 which is of type OSPF, and we can just see. So if you see, this is the OSPF hello packet. So all the formats that we have seen in the earlier videos, all the fields that you can directly verify from this simulation stuff. And now let's see what is happening. So yeah, it is being sent to router 1, since that is the designated router. So the hello packets will be sent to this designated router only. And yeah, we can just simulate stuff like that. And if you see, router 2 is also sending the OSPF hello packet to this, and this is the Cisco discovery packets that is being sent by router 0. So you should not much worry about these packets. So yeah, we can go to we can switch back to real time again. Now one more thing to note, that we have backup designated router and DR and BDR elected for this topology or for this OSPF configuration. But since this topology doesn't much rely on the PR and DPR, because we don't have any other router connected to any other router of this, it's just this point-to-point connection. So in this case, what we can do is we can just go to on the router 0, and from the global configuration mode we can just go to interface fast is 0/1, so which is the interface connected to router 1, and we can have this command IP OSPF network point to point. Okay, so now if we just exit and show, if we just enter show IP interface, okay, we need to exit one level more, show IP interface brief. So yeah, if you see, all the interfaces are up, and we can just hit show IP route, and yeah, routes are also fine. Okay, we don't have the routes yet, so let's go to show IP OSPF neighbor, and yeah, if you see, we have stayed full. Now there is no DR and BDR over here because we have made this connection as point to point, which means there is no other routers connected to this topology. So it should not worry about election of DR BDR. Basically, it will reduce your time. So you'll have a full state written over here, and if I'll just go to show IP route, so now if we are making this link as in point-to-point network, we should also make this link as in point-to-point, and I have made all the links point-to-point because it doesn't require to elect the DR and BDR. So now all the routes are being correctly shown over here, and if we just go and hit this show IP OSPF neighbor, we won't see DR and BDR written over here, so this is just state showing as in full. Also on the router 0, if you just go and hit show IP OSPF neighbor, OSPF, okay, we need to go one level back, so show IP OSPF neighbor. So if you see, both of the neighbors are showing full state instead of DR BDR stuff written over here. So yeah, I hope you have got the idea about how we can configure OSPF protocol on the Cisco devices through the Cisco Packet Tracer. So I hope you have liked this demo and want to see more videos like this in the future. So make sure to subscribe to our channel, and if you have liked this video, then consider giving a thumbs up and write a comment about what are the future videos that you might want. And if you want to have any general chit chat in the comment, that's also really appreciated. And yeah, we'll meet in the next video. Till then, keep learning and keep exploring.